I'm going to go over the solution for problems 31 and 33 over linear programming. And you can follow along. This would be on page 281. And if you look at problem 31, and then again if you look at problem 33, the solution is really provided for you in the table on the bottom of that page. But let me go through problem 31 first, and then I'll go through problem 33. So what I have up here in my table, right, I've already put the values in for the two variables, x and y. And this was maximization. And in the problem, right, in other words, we know that we have a profit for each unit that we sell of x. We're going to make $5 and $6 for each unit sold of y. We have two constraints, right? So we have 2x plus 1y. And always make sure that you always put a 1, like the problem. In the problem, it stated 2x plus y. Well, we know that y is 1, so just put 1 in there. And it's less than because, well, in other words, it's maximization. And the total hours, or whatever it may be, resource available is 120. And likewise, for the second constraint, right, we were given 2x plus 3y, and the total resource available hours, whatever it may be, was 240. Okay, that's the problem. That's how you should have set it up if you were setting it up for our QM for Windows. And then we would go ahead and solve it. Let me just zoom it out a little bit. We'll zoom it out. Let me bring that back in. Get my screen. Zoom it back to 150. And that's what we have. That's the solution. Is, in other words, the optimal output solution for this problem, given that our objective function is maximization, would be to produce 30x, 60y, and our maximization of profits would be 510. So this is the optimal solution, output 30, 60, and that's the profit picture. And that's what it's calling for in part A of 31. What is the optimal solution for this problem? 30x, 60y. And then it says, in part B, if a technical breakthrough occurred that raised the profits per unit of x to 8, would this affect the optimal solution? Once again, when they're saying optimal solution, they're focusing in on 30 and 60. Well, for this particular situation, we want to go to our ranging factor. And in this particular table, that will provide us with the answer to this particular question. And you can see in the top half, we have the value, 30, 60. We have the original value, right, 5 and 6. And the problem is stating, once again, that because of the technical breakthrough, the profit per unit of x is raised to $8. Right now it's at 5. Well, when we look over here at the last two columns, we have a lower boundary and we have an upper boundary. And this is telling us is that if the profit is between $4 and $12, it will not change the optimal output solution of 30 or 60. In this case, since we're focusing on x, the value would be 30. Well, if it goes to $8, right, we're within the boundary of 4 and 12. So no, it would not change our optimal output solution of 30 because it is within the boundary. Now, when I'm talking about between, we do not include 4 and we do not include 12. Between 4 and 12. And then in part C, it says instead of an increase in the profit coefficient X to $8. Suppose that the profit was overestimated and we would only have 3. Now, does this change the optimal solution? Well, it very definitely does, right? Because the boundary, the parameter is 4 to 12, and we're sitting at 3. So yes, it would do that. Okay, if we go on to problem 33, and once again, as I mentioned, in other words, that table there on the bottom of 281 is the output for this particular problem. So it states in 33, in part A, how much could the profit on X increase or decrease without changing the values of X and Y? Well, as I've already pointed out, right, for problem 31, between $4 and $12 between. We're not including 4 and we're not including 12. If we would include 4 or we would include 12, it would change the optimal solution. You might say we would have a dual optimal output solution. For B, it says that the right-hand side of constraint 1 were increased by 1 unit. Okay, constraint 1, we have the original value of 120, and we're saying if we increase, if we can go out and hire 1 more unit of whatever that resource is at 121, how much would the profit increase? Now, let me say a little bit about that. Let's look at the second column here, where it talks about slack surplus. And you can see we're talking about constraint 1, and you can see a 0 there. That simply means that given the optimal output solution, 30/60, we have utilized 120 of what, say, hours. We have completely utilized everything. So we have no slack left. It's 0. So when you see in your slack or surplus column a 0, that is the saying is that you've utilized whatever, in this case, we've utilized 120, I'll just say hours. We've utilized 120 hours to arrive at our optimal solution. So therefore, if I can go out and hire 1 additional hour, right? And I'm okay because, hey, we got this lower boundary and we got this upper boundary. So this is telling me that, in other words, I can go between 80 and I can go up to 240, but not including 240. And in this case, I'm okay, right? If I go 121, I am in between my lower and upper boundaries. And if I can hire 1 additional unit, that tells me my profit will go up by 75 cents. Now the question usually comes up, what about if there isn't a 0 here? What about if I had like 10? Well, if you've had 10 and if you increase, say, to 121, it's not going to have any impact on profits at all, because all what this would do is you'd increase inventory. It would only have an impact on profits if we have a 0 here, which simply means I've utilized all what this resource happens to be, and if I hire 1 more, it'll be 75 cents. Likewise for constraint 2, right? I got a 0 here. That simply means I've utilized everything. 240 hours, hypothetically. I've utilized it all. So therefore, in this case, if I would go to 241, right, you can see my boundaries. 240 is between 120 and 360. If I increase it by 1, guess what? I'll be making an additional $1.75. Or if I would bring it, say, to 119, I'd be losing $1.75 in profit. So the key element here is to always, is there a 0? That simply means the constraint is bounded, meaning I've utilized it all. And if I add 1 additional unit, hour, whatever it may be, that's my profit picture. So in C, if the right-hand side of the constraint 1 were to be increased by 10 units, oh, we're going to go from 120 to 130. Guess what? 75 additional cents. So 75 cents times 10 would give me $7.50. My profits would be increased. So the proverbial bottom line here is when you're kind of looking at the what-if analysis, simulation you might say, is that you're always kind of looking at this slack surplus. If there's a zero there, hey, if I add an additional resource, it's going to increase profits. If you have a value here, if you have a value, 1, 2, 3, 4, 5, all what would happen if you would add an additional unit, it would simply go, you might say, into inventory. So hopefully that'll help. Quick overview of the solution for problem 31 and 33 on page 281 of your